All right, so today we're going to be talking about asynchronous JavaScript. And asynchronous JavaScript is everywhere on the internet, and most people would agree it's probably one of the best things that ever happened to it. And whether or not you've noticed it, you have definitely used asynchronous code. If you use Facebook or Twitter or YouTube, you've used that because you've noticed that you scroll to the bottom of a page and there's just more content and more content, which is arguably a bad thing in terms of human psychology, but in terms of usability, it's great. And the reason for that is asynchronous JavaScript. And same thing with Google Maps. If you load up Google Maps, you can zoom in and out of the page and see different businesses based on how far you scrolled in and out. They didn't load all of that when you first load the page. So if we start a new window, one sec. Having multiple displays is sometimes a pain. Go to maps.google.com. So if I zoom out, when I first loaded the page, it had everything about my neighborhood, but I can zoom out, zoom out, zoom out, zoom out. And then, zoom in on France and figure out some, good stuff about what's in Paris these days. And I can see, okay, I want to learn about the Arc de Triomphe. Google didn't load this page with all the information on the Arc de Triomphe and everything else in Paris when I first started the page. That would take forever. So essentially, these are asynchronous requests. Whenever I make a request, whenever I change anything, scroll out, zoom in, click on something, that's an asynchronous request being made. And so essentially what asynchronous requests allow us to do is they allow us to make changes to data displayed on the page without having to refresh the page. So today we're going to be learning how to use that. And in the past, we've been a very common way to do that was a library called jQuery, and that was used to make asynchronous calls, also called AJAX calls. And you may see this in the future in like legacy code or on Stack Overflow when you're trying to figure out how to do something asynchronously. They'll still assume you're using jQuery. But the more modern way, and the way we're going to learn today, is using something that's pretty new to JavaScript called the Fetch API, which can allow you to make both GET and POST requests. And kind of going back to the slides we were talking about earlier, GET and POST. The GET method is used for what's called non-destructive operations, meaning things where you're only getting data from the server and not changing it. But POST requests are used for destructive operations, meaning where you're changing data on the server sometimes, such as posting a comment. So I'm going to open up my code that I have here. Any questions on everything I just talked about? I know we haven't really gotten to how asynchronous code works yet, but any questions on how, and why we use it and where? Okay, I'm going to create my HTTP skeleton and change the title to JS and fetch. And I'm also going to add connect my app.js file. So src equals app.js async differ. And I'm going to add some stuff here. I'm going to add a div, give it a class of container. Inside of that, I'm going to add an h1. I'm going to give it an ID of heading. Say, welcome to my web page. I'm going to add a p tag. This one's also going to have an ID of, we'll call it article 1. This is a fascinating article. And then underneath this div, I'm going to put a second div. I'm going to give this one a class of response data. And so we're going to be using this as a skeleton to allow us to use fetch with. So I'm going to do a few. So in app.js, I'm first going to grab my response container by saying const response container equals document.querySelector. And I want it to get something with the class of response data. And then I'm going to create my fetch request. And to use fetch, it's pretty simple. You just use the word fetch. And then you give it a URL to fetch to. In this case, I'm going to go to a website called jsonplaceholder.typicode.com. And so if I open a new tab and visit that, what I have here is JSON data. And the reason it looks so nice is I'm using a Chrome extension called Json Reader, I believe, Json Viewer, which pretties it up and makes it look nice. Normally, it would look something like this. So I want to make a fetch request to grab this data right here so that I can bring it into my JavaScript file and then render it to the page. So I'm going to make a request to jsonplaceholder.com. And then I'm going to just implement it now and then show you what it means afterwards. I'm going to say .then resp.json. And then I'll add another .then that says JSON equals. And then I'm going to put brackets here so I can put this on another line. Response container .inner HTML equals JSON.title. So I want to see if this works. I'm going to open it up. And there's the Delectus autumn from here. So I'm going to break this down line by line. Our first line 3 here, we make a fetch request to HTTPS. And by default, we don't need to specify that this is a GET request. The default fetch request is always a GET request. And then I'm going to kind of show you something of kind of what happens when I do that. If I console.log fetch, we should see something interesting. So we see something called a promise. And promises are kind of at the heart of asynchronous code. So I've been throwing around this term synchronous and asynchronous there. So synchronous code, does anyone want to take a shot at saying what synchronous code is, which is our usual code? Like if I do const response container equals that, and then I console.log hello, console.log goodbye. What's kind of happening here, line by line?
I'm gonna guess that based on your explanation of sites that use asynchronous code, that synchronous code has sort of a beginning and an end all on the same page of JavaScript, whereas asynchronous code has some sort of mechanism for leaving it open-ended.
Yeah, that's very, very close. So essentially, when JavaScript code goes line by line, and each line can only run when the line before it is done resolving. And typically that doesn't take much time at all. But if I do something like, if I go set timeout for just kind of do something like a placeholder there, and I set it for 1000 milliseconds. Okay, that didn't work. I forgot how the set timeout works. I do window.set timeout. So what I'm hoping for is that I set a 1-second timer in between hello and goodbye. I'm a little rusty on how set timeout works, but the idea was this line 3 wouldn't be able to run until the timeout was finished. What asynchronous code allows us to do is it allows us to do something like run a fetch. Just going to delete all this. Get something from an outside resource without slowing things down, without having to wait for it to finish. Because what's the problem if we're fetching from some huge resource? What could happen on the web page if it wasn't asynchronous?
Nothing else would load until that's done.
Exactly. Anything else I want to do to this web page would have to wait until this fetch request is resolved. Sometimes fetch requests are very, very fast, but other times they can take, several seconds or minutes even, depending on the size of the resources you're trying to access. So using asynchronous code, we can mitigate that by saying, okay, while this fetch request is happening, I can do other stuff. So if I do fetch request, so if I do something like, console.log, so the fetch request, this actually happened before the fetch request is resolved. If I do console.log fetch here, put that back the way it was. So at the moment, the fetch request is actually quick enough to catch up to this. But if this was larger, we could get to this line before this one was finished resolving. And the way it works is by using these things called promises. So when you make a fetch request, it immediately returns an object called a promise. And that promise starts out as pending and eventually will either be fulfilled or not fulfilled, depending on how the request goes. So that allows the fetch request to return something while other stuff goes. And the only way to access the return value of this promise is to use a function called .then. And .then specifically runs saying, okay, once the promise is resolved, we're going to do something. And essentially what I'm doing here is I am saying, okay, use this response. You can call it anything you want. The first thing I'm doing is parsing it from JSON into an object that we can read. I could just change this to console.log resp, like so. And so this is the response that I get. So I've got things like headers, URL. This is I get all of this stuff right here. And I could say, okay, I want a console.log response.json. So I'm parsing it from JSON into a JavaScript object. And that gives me the promise result. And here, the promise result is the thing I really want. So essentially what the first thing I'm doing is I'm saying, okay, take the response from this fetch request once it's resolved, translate it into JSON, and then we have and that returns another promise. So we're using a second .then. We're saying, okay, take that JSON, and in this case, turn the inner HTML of response container into the title of that JSON object. So again, if I do a console.log JSON down here, this is the object that this line returns. Great. What questions do you have about fetch promises, and .then?
Just to reiterate, the RESP that you have there, you said that could be anything you want. It's however you label it.
Yeah, so the RESP is just essentially assigning the return value of this to a variable. So I could call this,
Okay.
response, and it would still work fine. Same thing with this. That's just saying we're taking it, essentially when you use a .then, this first part is going to be the return value of the promise before it, and then you just do whatever you want with it. So it's just a word saying return value of whatever came first.
I have a question.
Yes.
So if you want that data that you just retrieved and you want to be able to loop over it, use it in a variable, you know, for other functions in your code. Where would you assign that variable? Can you assign it right here, you know, inside the body of the fetch request and access it? Is it accessible outside the body of the fetch request, or do we have to set a global variable and assign
Let's check that out.
it?
So JSON is not defined when I ran that. So I can't access JSON or response outside of these things. They're outside of scope. So typically, if I want to do something else with that in another function, perhaps, I could do something like write a function that says, you know, call this one show data, and it takes data as an argument. And I could just say, inside this dot then, I could say, I want a console.log data. And that would just say, you know, use show data on JSON. So the easiest way to do that, if you want to do things specifically outside of that, is to write a function outside of the request, and then call on that function inside the request and give it something as an argument. Does that answer your question?
Yeah, so you would just then you would assign a variable to that function if you want to, and return the data from that function if you want to use it, persistently.
Yeah, something like that. Yes.
Okay.
And yeah, as you'll kind of find, the more you go through challenges and things like that, you're going asynchronous code really forces you to rethink how your functions are organized. And so you'll be able to see that the more you work on it.
Sorry, no, I have another quick question. This fetch request that we have here, and we're using these dot thens, what if we wanted to do another, when does it determine that the dot then isn't for that actual fetch request right there? What if we have more than one fetch?
Yeah. So the dot then, just because it comes after the line after this one, means it's specific to this fetch request. So I could actually chain it together like this. Oops. Like so. Because essentially dot then is specifically chaining onto whatever the return value of this fetch is. So it won't get confused if we have another fetch request above it, because that fetch request, the same way that if I do console.log, if I do something like response container.innerHTML and also document.innerHTML, these inner HTMLs belong to different things: response container and document.
Okay. Thank you.
No problem. All right. Any other questions before we move on to talking about how to do a post request?
I'm sorry, Noah. I'm still a little bit hung up on what James had asked about the show data, like on line 3 there. So is there, because then the way I see it, that's still a function in itself. So if I try to use that data that I'm getting from that fetch request somewhere else in the program, like that function wouldn't really help me, because I would still need to feed it an argument data. Like, is there a way to assign whatever you get from, like, on line 10, like assign it to a variable that I can like reuse in other parts? Like if it returned like an ID or something, and then assign it to a variable and then use that in other places in the code. Are you allowed to do that?
Yeah, you could do something like, okay, let title. And then here I could definitely say, let's see if I do title equals JSON.title, and then down here. So it doesn't break. That's good. The problem is we need to make sure we understand when we're accessing title, because if I console.log title down here, let's see what happens. It says it's undefined, because this line right here runs before the fetch request is resolved and before this variable is reassigned. Because these two lines right here are running synchronously, but this is running asynchronously. So if you want to have a variable outside of the asynchronous function, you'll want to make sure that anything you do with that title is done within a .then or some other way of resolving a response, a promise. Because otherwise, it'll just run it before this fetch request is done resolving. Does that make sense?
Yes, it does. Thank you.
Mm-hmm. Yeah. So typically, the more you work with asynchronous data, it's, these .thens can start to get pretty crowded, and you can just keep on chaining .thens together if you want to.
So instead of assigning it to a variable like the JSON data, like title, what would be the best way to, you said we would use a .then to access it later, say we have several functions, we're several functions down, and how do we use the .then to access that?
So essentially you would say, okay, you could do .then right here. And then you could say, all right, at this point, you can do whatever you want with title. You could console.log title. You could, so if I do console.log title here, so the first time it's undefined, the second time it's select is sought autumn. And any other functions I've written, I can still call on as well. So if I do, write a function here that says, const display title here, and its only job is to console.log title, I can still call on that function right here. And it does the job because it's inside of this. It's saying, okay, make sure you don't do this until this fetch request is resolved.
So it's normal for your fetch block to get pretty big then with all kinds of functions and stuff like that?
It's possible. Often, but like typically you don't, typically whenever you grab data from an outside source, there's only a couple things you're going to want to be able to do with it, which in the most common use case is parsing it from JSON and then using it to update your HTML somehow. But other things we may find ourselves doing is maybe if you're going from like a whole database, you may have, say like let records equal an empty array here. And then you can continuously update records based on the information you get from your fetch requests.
No.
Yes.
Do you have to use the promises with a fetch request, or is this something you can use for, like, let's say a function that just takes, a minute to complete?
Yeah.
Could you technically make that return like a promise?
Short answer, yes, you can. A promise is just a JavaScript object, so you could tell your code you could make it write like a timeout function that returns a promise. I don't know how to do that off the top of my head, but it is possible.
Okay, cool.
Any other questions?
Can I see the index file again?
Mm-hmm.
Is it typical, Noah, to have like, say you're getting a big object or a big JSON data object, you only want to load that once and you want to use a bunch of different data from it. Do you just make another fetch request, to make things easier when you need it? Because this whole like using .then and then having it load when you need it to and doing things within the body of the fetch request seems like it could be tedious.
Mm-hmm. Yeah, I mean, so one thing you'll find is that you'll definitely have, many event listeners on your function as well. So an event listener won't have the same problem necessarily as other code because that code isn't running later. So if I had an event listener that says, okay, alert show title when you click a button, then I could say, okay, then it can access title as it currently is, as opposed to what it was assigned on line 3. So that you'll typically find that if you're using something, something like that, you'll be able to access it later with event listeners.
Oh, so because you assume it's loaded by that point by the time the event listener is called, basically.
Yeah. So for example, if I did, okay, response container dot add event listener, click, and then I said console.log title here. So when title is first assigned, it's undefined, and when this event listener is added, it'll be undefined. But if I click on it now, click it here, then it knows to find delectus ad autumn because it'll show me whatever title currently is. Because this function doesn't run until I click on the HTML element. Does that make sense?
Yeah, it does. Thank you.
Great. Okay, so let's move on and talk about posting data. So this is all GET requests we're talking about. So now I'm going to practice posting request. So I'm going to use a website that in the past has given me some trouble. So I'm going to warn you right now, it's possible that this will break. But there's a website called putsrec, which allows you to record HTTP requests and make fake responses. So I'm going to create a putsrec. And I'm going to copy some data here to make make a custom response. Like so. Update it. So all this thing does is it says, okay, message equals data. So I have this MSG here. I turn it into JSON using json.parse. Then if I say if request.body, meaning if I get a request, I grab, we're expecting something called body, which has a thing called name. And then we're going to return a response and say response.body equals MSG. So this is just kind of allows us to make, to mock a post request, essentially. Now I'm going to go to index.html. I'm going to make a form. I'm going to give it an ID of comment form. I'm going to give it an input. Give it an ID of comment. And I'm also going to give it a name equal to name. I'm going to write a button. Its type is going to be submit. And its ID is going to be submit comment. And then underneath this, I'm going to put another div. I'm going to give this one an ID of post response. So the idea is I want to be able to type in my name into a form, and I want to be able to add the response from putsrec into this div. To do that, I'm going to do a couple of things. So first, I'm going to say const form equals document dot get element by ID comment form. Make sure I spelled that correctly. Great. And then up here, I'm going to say form.add event listener. It's going to be a submit function. Actually, I'm going to do it the other way. We're going to event.prevent default. So now I'm going to create a response body that I can give to my eventual fetch request. So I'm going to say let comment equal, and I'm going to make an object. It's going to have a key called name, and I'm going to say that's going to be event.target. This is another way of getting to the value. I'm going to say target.elements 0.value. So event.target element 0 would go from event.target is the form, and elements would include the input and the button. And so the first thing would give me the input. And then I'm going to save the URL of my putsrec as endpoint. So let's see what the URL is. So I believe it's this. Now I'm going to do a post request with fetch, which works a little bit differently than a normal GET request does, because we need to specify that we're posting. So I'm going to say fetch. My first argument is going to be the URL or endpoint. And the second argument is going to be a big dictionary. It's going to have a few keys that we need. The first, I need to specify a method. So I'm going to say method is post. Then I'm going to define some headers. And I'm going to say content type. So what we're sending in is application JSON. And then I'm going to send a body. And the body, and it's going to be the comment. So I'm going to say, I can't send in the comment as is, because right now the comment is a dictionary or an object. And I need to convert it into JSON. And to do that, I'm going to use the method json.stringify comment. So whenever you make a post request or another type of request using fetch, you need to specify a method. You can specify the headers, which is usually another dictionary. And then you need to give it some text as the body, typically using json.stringify to translate an object into a string. Once we've done that, I'm going to do another series of .thens similar to the GET request. I'm going to say .then response, and I'm going to parse that response from JSON again, just like we did for the first time. I'm going to say .then JSON. I'm going to say let post response container equal document.getElement by ID post response. I'm going to say post response container dot inner HTML is going to equal JSON.data. So let's see if this works as it works the way it's supposed to. I've got my form here. I'm going to write a comment. Hit submit comment. So my response is hello, hello world, because I told it that the message is going to be data equals hello plus body name. So if I just type in my name this time instead, it says hello Noah. So that response is sent back as JSON the same way that this JSON was sent to us earlier. We parse it into a dictionary, and then we can do whatever we want with that data in the second .then. Okay, what questions do you have about posting data? I will say, don't feel the need to memorize how to post data with a fetch request. It's a lot to remember. It'll come to you in time, but you can always come to today's lesson plan to kind of get the general format. So that way you don't need to remember method, headers, body, all of that. But this is the pattern you will typically be following when making a post request. Okay. So let's take a look at the challenges for today then. So your first one is simple to do. So you're going to be creating a simple to-do list application. Every developer that makes one sooner or later, so this is your chance. So this one is pretty open-ended. So you're going to create HTML, CSS, and JavaScript files. Your goal is to display a list of items that you need to do, and you'll be using local storage to get and remove and add these items. You're going to create a form at the bottom of the list to add more things to your to-do list. And you'll create the ability to check off things from your to-do list. And when you check things off, it should have a strike through it, so you know that it's done. And then you'll need to make sure, okay, that'll probably alter how your data is stored in local storage. And then finally, you'll want to style it. You can use this, make a good chance to try out Bootstrap if you want to do something other than vanilla CSS. So again, we don't give you too much guidance here. You now have all the tools you have at your disposal that you need in order to make this. Any questions about the simple to-do page? Okay. And the second one is HTTP server 1. This is the first part, and I believe a 3-part challenge. So this is only the first one. So for this challenge, you're going to be using Python to build your own HTTP server. So some of this is going to be familiar. Some of it is going to be entirely new. And it says, don't worry. The point of this exercise isn't to become an expert at building servers. There's going to be stuff you're not getting. That's all right, because typically you don't need to build your own server from scratch. That's, there are tools that do that much better than we can ever do. The point is to kind of practice separation of concerns like OOP and OOP principles, and kind of hammer in these so you make sure you understand as much about HTTP as we can. So you're going to be using requests right here. You're going to be making a TCP server library called Socket that's built into Python. And so this one right here is going to help you create a hello world server. And it's going to walk you through all the steps you need to do that. It also suggests other ways to make requests to your server. So you could use Chrome or any other browser. You can also use a tool called Postman, which is super useful. I recommend downloading Postman even if you don't use it today. It allows you to make requests with a GUI. You can also use curl from your command line, but Postman is super helpful with this stuff. Then it's going to be things like how to keep your server running. And then eventually you'll be adding HTTP protocol to it and parsing a request, and then using OOP to separate these things out. And then after you've done all that, we'd like you to test your server using fetch from a JavaScript application. And then a stretch goal for today, if you finished all 3 of these, is creating a static web page. So this will essentially be your chance to recreate this website, this fake website here. Great. What questions do you have about today's assignments?